Team Xile here. We've been working on a data repository named Xile. As part of the production process, our team has managed to outline a software development workflow with relevant tools to assist in proposed practices and methodologies. So, for test first development, these are test cases that are written before the code itself. At that point, they are impassable. Code is written specifically to pass a given test case. When the written code successfully passes the test, the passing code is refactored into a more elegant module without introducing any new functional elements. If implemented correctly, it can be carried out 5 times in an hour, and this ensures the end product has been successfully tested at every step in its development before adding more improvements to the functionality of the program. So when the program is changed or enhanced, regression testing is done for any new bugs or regressions that may appear. Common methods of regression testing include rerunning previously completed tests and checking whether program behavior has changed and whether previously fixed faults have re-emerged. Benefits of this type of testing is that we can fix them in early stages of development where they can be easy to resolve and minor obstacles for us, rather than later at the end of final stages of development when they can be very difficult as they may have built up over time in development and be larger obstacles to resolve.
Automated acceptance testing is also an important part of our workflow. An acceptance test is a test for a particular piece or section of coded software. These tests are created based on what the user has provided as their requirements. Usually, each user story is assigned multiple acceptance tests. Once the software pertaining to each user story passes its acceptance tests on an acceptable level, it is deemed to be complete. Acceptance testing does not involve any coding like unit testing would. As long as the piece of software does what it is required to do, it could be considered to have passed its acceptance test. Automation of acceptance testing is important in delivering high-quality software. Using automation software helps to manage acceptance testing in a timely and formal manner. One such software is Eggplant, which is a free and open source automated acceptance testing software provided by Testplant. It provides many features that help with acceptance testing and has a strong trait in that it can cover any platform and any technology.
Version control plays a huge part in the software development workflow. We feel it is of utmost importance to make it an integral part of a software project. This is because version control helps keep projects on track and allows for more stable implementation, knowing you'll always have a previous version to fall back on. There's a variety of different platforms and methods to choose from when considering how a group is to implement version control into their projects. We found that a distributed version control system such as GitHub is ideal for collaborative software projects such as ours. This is because using a local method of version control is hugely prone to error, and it can cause many complications in the long run depending on how many people are involved. A distributed version control system, also known as a DVCS, doesn't just take the latest snapshot of the files. Instead, it fully mimics a repository. This suggests that even if a server were to die and the systems collaborating within it, any of the repositories would be able to be copied back up to the server and be fully restored. This is possible because the repository has been mirrored and each clone is really a full backup of all the data. GitHub doesn't only cover version control, it also plays an important role in the use of shared code. With GitHub, we can see in real time changes to code while having the options to merge, pull, and push code with ease. This helps accelerate our collaborative project's production by reducing the time spent working out a way to share code while also eliminating the need to arrange only physical meetups. For example, if we were to assign one of our group members to design the login UI, while another to work on some functionality inside the software, they could both collaborate in real time over GitHub. This would allow them to analyze changes and make note of each other's progress as they continue integrating the project's full functionality in one place. This also means there will be a record of every change and every version. This is exactly why GitHub is an extremely powerful tool, and we believe at the very least, every software project workflow should consider the use of GitHub. Continuous integration, in short, is a software practice where team members integrate their work frequently. This integration is then verified by an automated build to detect errors as quickly as possible. Many teams have found this approach has led to significantly less problems and that it aids in building cohesive software at a faster rate. Because of this, continuous integration can be seen as an efficient practice to undertake when considering your software development workflow. We feel that a continuous integration tool such as Jenkins would be optimal in the undertaking of a decently sized software development project. The main purpose it would serve is to help identify potential bugs earlier on, thus increasing the overall cohesion of the software. Although continuous integration doesn't strictly get rid of bugs, the ability to see them earlier is exponentially more valuable the earlier you notice them. This is because bugs are more often than not cumulative. The more bugs that present themselves, the harder it is to rectify them and get to the root cause. Projects with continuous integration tend to have dramatically less bugs. This is why we feel Jenkins would prove extremely useful to any software development workflow serious about their product's cohesion and overall quality. Not only this, but having continuous integration allows your users to get more features rapidly and more feedback on said features, and generally become more collaborative in the development cycle. This is the very core of Agile fundamentals.
Build automation is the use of software to manage the rather wide variety of tasks that software creators must do on a daily basis. Creating builds is important for conducting all manner of testing in order to find bugs and ensure that software is meeting requirements. Automation of this process is important in saving time and conducting these tests in a timely manner. Such builds can be run overnight with a report for the developers to work on from the next day. Maven is one such tool that works with the popular IDE NetBeans. It is a free and open source piece of software that helps with build automation. Like NetBeans, it is a good beginner tool to use and has a wealth of knowledge online to help with any problems or questions you might have.
With rapid prototyping, we are able to develop prototypes of the system to get a better understanding of the system we wish to create rapidly and efficiently. An example of a tool to support this is a website called mockups.com, which allows us to create concepts and semi-functional components of the Xile system.
Thanks for taking the time to hear our software workflow propositions and recommendations. We hope it'll assist you in your future endeavors.
And a big thank you from Team Xile.